Let's look at a skydiver whose mass is 75 kilograms, who steps out of a plane flying high enough above the ground to reach terminal velocity and falls towards the Earth under the influence of gravity. Terminal velocity is the maximum velocity a falling body can achieve as time goes on, or as t approaches infinity. That is, if v of t is the velocity of a falling body at any time t, then terminal velocity, v sub terminal, is the limit as t approaches infinity of v of t. What this means is that a falling body will reach a maximum velocity based on a number of factors, and even if it can continue to fall, it will not exceed that velocity. So assume that our skydiver opens the parachute immediately after leaving the plane. That gravitational force remains constant throughout the fall, and resistance is proportional to the velocity of the skydiver with the parachute open. Then the velocity of the skydiver can be modeled by the function v of t equals negative 4.905 plus 4.905 e to the negative 2t. What we want to do is find the terminal velocity of the skydiver for this jump. Now, given that our mass is in kilograms, we know that the units for this particular velocity will be in SI units, so this would be meters per second. All right, so we're after the terminal velocity, so v terminal is going to be the limit as t approaches infinity of my v of t. So that's the limit as t approaches infinity of negative 4.905 plus 4.905 e to the negative 2t. Using my limit laws, we can rewrite this as the limit as t approaches infinity of negative 4.905 plus the 4.905 times the limit as t approaches infinity of e to the negative 2t. Well, the limit of a constant is a constant, so this limit as t approaches infinity of negative 4.905, that's just going to be negative 4.905 plus 4.905 times, and now we need to consider what happens to this limit as t approaches infinity of e to the negative 2t. So let's take a little aside here and note that as t approaches infinity, negative 2t will approach negative infinity. So we're going to let u equal negative 2t. Then we can say that the limit as t approaches infinity of e to the negative 2t is the same as, has the same limit as the limit as u approaches negative infinity. Note that that's the case because u is negative 2t and negative 2t approaches negative infinity of e to the u. And what do we know about the behavior of the exponential function? You might have a mental picture in your head that the exponential function behaves roughly like this. So as u approaches negative infinity, this exponential function approaches 0. So we now know that the limit as t approaches infinity of e to the negative 2t is in fact 0. So simplifying this expression, we get negative 4.905 plus 0, or just negative 4.905 meters per second. Now we want to know how long it takes for the skydiver to reach 50% of its terminal velocity. So we found that the terminal velocity of the skydiver was negative 4.905 meters per second. And what we want to know is, when does the skydiver reach 50%? So we want 50% of V terminal We want to find what time, so we're going to basically set that equal to V of t, and this basically creates an equation that we solve. So we want 50% of our negative 4.905, and then we use our velocity function to help us find the value of time at which this happens. So negative 4.905 plus 4.905 e to the negative 2t. So let's go ahead and multiply out the left side of our equation. And in doing that, we get negative 4525 equals negative 4.905 plus 4.905 e to the negative 2t. Now let's add 4.905 to both sides of the equation. So plus 4.905 plus 4.905. In doing that, we end up with positive 2.4525 equals 4.905 e to the negative 2t. Now dividing by 4.905 on both sides of our equation, we end up with 0.5 equals e to the negative 2t. Now we're solving for t, so we'll take the natural log of both sides of this equation. So we get the natural log of 1/2, or 0.5, equals negative 2t, which then implies that t should equal natural log of 0.5 over negative 2. Now, that's the exact representation of the time at which the skydiver reaches 50% of his terminal velocity. But to give you a sense of how long that is, this is approximately 0.3466 seconds. Now, that is a rather short period of time. Recall that we're only looking at 50% of the terminal velocity, and also recall that the parachutist opens the parachute immediately after leaving the plane. I hope this helps.